Okay, starting with number 6. So that is, the pages are not numbered, but it's the second page, I believe, right? Yep, second page. All right, ready? I thought that this one was the most difficult one, and I'm going to tell you why. If you follow the same way that you did this on the quiz, it doesn't work. On the quiz, when you had this trapezoid and you put a line going down here, it would have worked. It doesn't work here, and I'll show you why. We have a triangle. I'll label it. We have a triangle, and don't write this. Just look at it, because this way will not work. Triangle, triangle, rectangle. Let's do this rectangle first. Do you have a base? And if so, what is that base? Dave. Right. Do you have a height? Matthew, what's the height? And you can multiply these two numbers to get the area of the rectangle. However, go to triangle 1. Do you have a height?
Yeah.
What's the height? Brandon, you have a height. Do you have a base? Not only do you not have a base, you can't figure it out. This long piece here is 39. In order for me to figure out what this is here, I have to know at least this. This I have. This is 17. I need to know this in order to figure out this, and I can't do it. So you can't break it up this way. Only way to break it up, and it actually winds up being easier, is 2 triangles. So this I do want you to write. I'm going to erase everything here. And watch what we're going to do. I'm going to break it up this way into 2 triangles. Okay, if you didn't get a chance to do that now. And what I will do, because we're kind of short on time, I don't want to write out all the formulas and substitutions. Let's do a little bit in our head. Triangle 1, triangle 2. Label it. All right, ready? Triangle 1. I'll do it in green since I've already started in green. Do you have a base of triangle 1? And if so, what is it? Patrick. 17 is the base. That's this. Do you have a height? It's 16. It is. Because look, this is an obtuse triangle. The height is from here to the tip. Here to the tip. This dotted line is representing from base to height, also known as the altitude. So, what's the formula? Okay, and I'll tell you because I'm going to help you out. 17 times 16 divided in half will get you 136. Write that. We're going to kind of skip the middle steps. We only have 10 minutes left. Okay, triangle 2, I'm going to do in red. What's the base of triangle 2? Ava?
39.
Correct. What's the height of triangle 2? M. 16. It's from here to here, which is the same as the dotted line. 39 times 16 split in half gets you 312. And I'll put an A equals here just so you know what these numbers are. Again, I'm just taking shortcuts because if you're going to write everything out, we're not even going to get past one problem together. Okay, at this point though, do you have questions on what we've done so far? Patrick? I took, Patrick, 39, which is my base, times my 16, which is my height, because that's my height. 39 times 16 divided by 2 is 312. Good? Amanda. Okay. Back me up and tell me what you want me to go over. What piece? All right, I took this and I divided it up into two triangles. Did you get that? Okay. Triangle 1, the base is 17. Base is 17, the height is 16. Do you see that? 17 is my base. My height, remember my height is from here to here. That's my height, here to here, which is 16. Good? 17 times 16 divided by 2 will get you 136. That height part, because look, it's an obtuse triangle, so my height has to be outside of the triangle. What about the red triangle? Are you good with that? Base is 39, height is that same 16. Split it in half, you get 312. But I'm still not done. I got to add it together. But Dan, what's up?
I got that right. I did the thing you said not to do.
Which is? Which is what?
I got it right.
You can, but you're using this dotted line not to find the area of this triangle, but the area of the large triangle.
I still got it right.
I'll have to take a look and see. Now all I got to do is if I add 312 and 136, if you add these two numbers together, you get 448 square feet. It's a hard one. This was like a hard one. I probably won't make one this hard on the test. Not like this. Abe.
So do you always add the numbers together?
If you're decomposing, you do. If you're breaking up a larger shape into smaller shapes, then you add the smaller shape plus the smaller shape. If you make a large rectangle around the triangles or the parallelogram or whatever it is that you're doing, that's called composition, and you subtract. All right, give me a shout out. What do you want to do? How many of you? Let's do a survey. Whatever gets the most votes for the ones that you got wrong, I will do. And I'm not going to do 1, 2, or 3. I'm going to do it on the blog site. What about problem 4? Raise your hand if you got it right. Number 4. If you got it right, raise your hand. Okay. What about 5? Raise your hand if you got 5 right. All right, let's do number 5. I'm working backwards, but that's okay. That's this guy, right?
Yep.
Abe, this would be one of an example where you're going to do composition and then subtract. Okay. I'm going to find the area of the entire rectangle first. I'm going to outline it in green because I'm going to skip the formulas because we don't have time. Let me do the height first. What's the height? That's the easier of the two. What's the height of the rectangle in green? Pete, 15. I'm going to write it just so we can see it. The critical question is, what is the length of the base? Caitlin. It's not 16. See, look, because I'll show you why, Caitlin. Here to here is 16, but I need the whole cut. I need the whole side. Lauren.
24.
Right. How'd you do it?
I added 16.
Right. It's from here to here is 4. Here to here is 16, and here to here is another 4. You got to add all of that up. When you do that, you get 24. And I'll do the math for you. 15 times 24 is 360. Now what? 360 is the whole rectangle, but I don't want the rectangle. I want this piece, which I'm now going to outline in red. So what do I have to do next? Peter. and then do what? Right, I have to find the area of each rectangle and subtract it from my rectangle. Each triangle. I'll call this triangle 1, and I'll have to call this triangle 2. And the good news is they're small numbers, so we can do it in our head. Gus, what's the base of triangle 1? No, not the area, the base of that triangle. This 360 is the area of my whole shape. 4 is correct. What's the height? Dan? 15. 15 times 4 divided by 2 is 30. I'm going to put it, well, I need another color here because this is my triangles. That's 30. And these are the same heights and bases. So this side is 30. I got to subtract those 2 triangles from the whole rectangle. And if you do that, you wind up with 300. 360 minus 30 is 300. Pat? Because I don't want the whole rectangle. I want this piece, again, I'll outline it in red. I just want this piece right here. That's my whole piece that I'm trying to find out. So I did whole rectangle and then subtracted these 2 pieces out. Okay? Anybody still have trouble seeing that? Gus or Matthew, go get me a piece of scrap paper. The yellow scrap paper in that thing. And then get me a pair of scissors too. No, it's the yellow paper. That's all those exit tickets are now scrap paper. And get me a pair of scissors. Hurry up now. Hurry up. 1. I'm going to do a visual model for you. I don't know, maybe it'll help, maybe it won't. And scissors. I need you though. I need you to hold this. Okay, ready? As best I can. I'll get to your question in a minute, Abe. Modsy, this is going to fall on the floor. Grab it as it does. Oh, Matthew, you're good. Archie's the man. Oh, I'm good. Okay. Look, guys. That's the shape I'm trying to find the area of. To do it, we composed. We completed the trapezoid by tacking on these 2 pieces just like this. Okay? We did this. We composed it. Found the area of the entire rectangle. Then found triangle on the left, triangle on the right, and subtracted them to get the piece that we wanted. Does that help? Does that help?
Yes.
Right. I'm just trying to help you see why we need to subtract at the very end. Okay. Thank you. Thank you, Matthew. All right.
Can't you take away the 2 triangles and then just do the same for trapezoid? And then you still get 300?
What's the area for the trapezoid? You could do it that way, but then I'd have to break up the trapezoid into a triangle, triangle, rectangle, and then add it.
But can you just take away the triangles?
Well, let me go back to Gazette and show me. What do you want to do?
Look, you can I did use
Hold on a second, guys. What do you want to do?
take away the triangles and just do that.
How, though? What's the formula for a trapezoid?
It's A equals base 1 plus base 2.
I haven't taught that yet, though. That's 7th grade. Okay? If you can use it, Matthew, if you know it and you can use it, I'm fine with it. I'm just not going to formally teach it to everybody because it's going to just confuse them more. Yeah, you could. You could. What he's saying, and you'll learn this in 7th grade. Want me to show it to you right now?
No.
I'll show it to you, and if it's too confusing, then forget it. There is a formula for the area of a trapezoid that you learn in 7th grade.
Isn't it base?
It's here it is. It's base 1 plus base 2 divided by 2 times height. I'll just show it to you in action. The number we had was 300 that we had to come up. That's our answer, right? 300? Okay. Base is 16 here. But what's this base?
24.
24. Add 24 and 16. What do you get?
You get 40.
You get 40, right?
Mm-hmm.
40 divided by 2.
20.
20. 20 times the height. Guess what? 20 times 15 is 300.
Oh. I need to put this down.
Is it easier? I think it is easier. But for some, it's more substitution, and that's why they don't teach it in sixth. Well, they don't teach it in 6th grade because they want you to understand why it works. All right. I am going to blog the rest of these,
For this
and
one,
you can go online.
it's a little messy now because you said it was wrong, so I erased it all.
Yeah.
But then I did this.
What happened to the little recording thing?
But I did this, and then I did 17 times 16, 136, and then I did 39 times
Hold on, let me
16.
shut down the recorder and I'll look at it. Okay, going back to page 1, the very first page with finding the missing sides. I have to find this piece right here by subtracting the entire piece 26 minus the piece from here to here, which is 16. And if you do that, you get 10 millimeters. This piece right here is going to be a combination of this and this, which is 10 plus 12. And that equals 22. Number 2. Again, just keep in mind what you're trying to do to find the entire horizontal is you need to add up the partial horizontals. So I'm going to use this to find this. I know that 8 plus what I'm trying to find plus 1 has to add up to 13. And when you do that, you get this piece as 4. 8 plus 4 plus 1 is 13. Same rule for my verticals. If I have to find this, I could take the easy way out and I can just look at the cross here. And we know if one side's 5, the other side's 5. And as a matter of fact, that's the only way you can do it, because to try to do it by subtraction, I would have to tell you what it is from here to here. All right, last shape on this page. I have to find the large vertical, so I'm going to add my smaller verticals. I'm going to add that all together, my 9.2, my 8, and my 14.1. And that gets you 31.3 inches. Same thing with my horizontals. To find this, I need to add this, plus this, plus this. That'll get you 37. All right, let's go on to problem number 4. It's a triangle, so my formula is going to be base height divided by 2. What you have to remember with this is my base is just this piece 6 right here. It's not 11. And my height is 4.5. So I have to multiply those two numbers and divide by 2. And without doing all the substitution because of time, 6 times 4.5 divided by 2 is 13.5 square centimeters. 5 we did earlier. We also did 6. I'm going to move on to number 7. Number 7 can be done if you break up the trapezoid into this triangle right here. You just have to find these 2 missing pieces to do it. Now, it's not quite drawn to scale, but you'll see it will still work. If we take 36, subtract it from 42, that's going to give us 6, and that's going to make these pieces 3. Even though this is slightly off, this could actually be 4 and 2, but as you'll see, it doesn't matter in this case. It'll still work. So now that's going to give me 3 shapes. Got to just remember from here to here now is not 42. It's 36. So 36 times 24. When you do that multiplication, you get this piece being 864. Just for that piece. But I got to add my 2 triangles. This triangle, it has a height of 24 and a base of 3. And when you multiply that together and divide by 2, you get 36 here, and you get 36 here. And then add everything together. 864 plus 36 plus 36 will get you a total of 936. And that's squared inches. Okay, here comes number 8, the House of Horrors. Alright, kind of like it was done on the quiz. Think in terms of triangles and rectangles. One line will break it up into 2 shapes. You now have a rectangle, and we have a complete base and height. And you have Mr. Triangle, and the base is also 15, and the height you actually have to calculate because it is not 22. Since it's 22 from all the way at the bottom to all the way at the top, I need to take 22 and subtract what it is from here to here, which is 12. 22 minus 12 will get you 10 for the triangle. That's the height. All right, rectangle first. 15 times 12. That'll get you 180 for the rectangle. And then this is 15 times 10 divided by 2. And that'll make 75. And then you add 180 and 75 together. And you get 255 square meters. Alright, let's move on to this one. This one wasn't too bad. Most of you got this one right. 2 rectangles by creating it that way. You could also do it the other way and it'll work too. Either way, you have to figure out one missing piece or one missing side. Alright, this will be 1 and this will be 2. Base is 8. Need to find the height. In order to do that, I've got to look at my verticals. This plus this that we're trying to find has to make 6. So that's going to make this 3. And then 8 times 3, straight base times height. Multiplication gets you 24 for the large rectangle. And then this one, we do have a complete height and a complete base. That gets you 15. And then you add those 2 together and you get 39 units squared. Okay, number 10. line across. Base 16, height 7. And you'll get 112. I'll do it on the outside. 112 square units for that. That's going to leave you two sides to try to figure out with the triangle, though, because they're both partial pieces. Well, again, 7 plus what makes 13? And that would be 6. And then 8 plus what will make 16? And makes that 8. And that's 8 times 6. But because it's a triangle, you've got to divide it by 2. That becomes 24. And then add 112 and 24 together, and you get 136 square units. And then our last one. Now this has since been changed since it went to print. So on yours it's 8 feet. And I won't explain why I had to change it. We'll just leave it as is. It'll still be okay. So this is using composition. I'm going to find the area of the entire yard, the entire rectangle first. So that's base times height. 17 times 8. And when you do 17 times 8, you get 136. That's the whole yard, but now I'm going to subtract my lawn and my other lawn, my two lawns. So I'm going to do 8 and 3. That's going to make 24 for this piece. And then 6 times 6 makes 36. And I'm going to subtract that from 136. So 136 minus 36 minus 24 is 76 square feet. And that is everything.